What's up, everybody? In this video, we're going to cover USACO's 2022 January contest at the bronze level, problem number 1, Herdle. The cows have created a new type of puzzle called Herdle that has become a viral sensation in the bovine world. If you haven't played it already, there's a game called Wordle, R-D-L-E, that's very popular right now. Being familiar with this game will make this problem a lot easier. If you have an understanding of the rules of Wordle, this basically is just using the rules of Wordle. The problem will explain the rules, but actually playing it and kind of seeing how it works in practice really would help solidify. So if you haven't played it before, I would recommend just go to Google, search for Wordle. There's a million places you can play it online. But that would be a good way to prepare sort of for tackling this problem, is just making sure you're familiar with those rules. Each day, a new puzzle is released for the cows to solve. The puzzle takes the form of a 3x3 grid representing a field on the farm, with each square of the field occupied by a cow of a certain breed. There are only 26 possible breeds, each identified by a different capital letter in the range of A through Z. One is not told the pattern of breeds in the field. The goal is to figure them out through a series of guesses. So let's draw out kind of what that looks like. So we've got a 3x3 field, like this, 1, 2, 3, 1, 2, 3. And then we've got cows labeled by letters A, G, B, F, P, Q, G, R, S, or whatever. So we have to try and figure out what these cows are through a series of guesses, because we can't see this. This is hidden from us. This is the correct answer, which is covered up, and we will make guesses as far as what's in the field. In each guess, the cows enter a 3x3 grid of uppercase letters. So we will guess by providing a 3x3 grid, indicating a possible way the field could be filled with cows. Some of the squares in the guess might be correct. So for example, if I were to do this, let's do B, G, F, Q, M, L, Z, X, A, or something like that. Okay, some of the squares in the guess might be correct. These are highlighted in green to let the cows know they are correct. Okay, so we'll switch to green here. Things that are correct. Okay, so this is my guess over here on the right. This G is correct because on this grid, there is a G in that location. And that's the only thing I have correct. Other squares of the guess might be filled with a cow of the right breed, but in the wrong place. These are highlighted yellow. Okay, let's switch to yellow. So I have a B, but it's not in this location. So that B gets highlighted yellow. I have an F not in that location. So that would get highlighted yellow. I have a Q in a different location. There's no M at all. There's no L at all. There's no Z at all. There's no X at all. I have an A. It's in a different location. So in total, I have 4 yellow squares, and I have 1 green square. This is also very similar to a game called Mastermind. It's a very old board game. Yeah, basically the idea is you make guesses, and then you get hints as far as how close your guess was. In this case, I don't know for sure where the B, F, Q, and A are, but I know that there are in the solution a B, F, Q, and an A. And I know for a fact that this is where the G is located. So I'm going to use that information then to try and figure out my next guess to sort of hone in on making my second guess, if I was to make a sequence of guesses, which is basically what Wordle is. The number of yellow highlighted squares can help provide an indication of the number of cows of a certain breed. For example, suppose a guess grid contains 4 cows of breed A, and the answer grid contains 2 cows of breed A. Okay, so for example, if I have a guess that has 4 A's, and my answer has only 2 A's. Where none of the A's line up, i.e. none should be colored green. Okay, so I have like A, and then X, 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 X. And over here, I'll have like X, 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 A, X, X. So I have 4 A's over here, I have 2 A's over here, and none of them line up. In this case, only 2 of the A's in the guess grid should be highlighted yellow. So these 2 could be yellow, but then the other ones won't be. More precisely, if there are X cows of a certain breed in the guess grid, so here, for example, X is 4 A's, and Y less than X cows of this breed in the answer grid, so here I have Y equals 2 A's, which is less than, not counting cows in the right place that lead to green highlights. And this is actually a very important thing too. Once a cow is matched in the right location, it gets removed and it can't match yellow. So we can't have a single cow matching both as a green and as a yellow. We'll come back to that in a minute. But if Y which is 2 in the answer grid, is less than X, which is 4 in the guess grid, then only Y of the X cows, which means only 2 of the X cows in the guess grid, should be highlighted yellow. Now, they mentioned something that was, and this will be more apparent when we see the example case below, but I want to pay attention to it here. Not counting cows in the right place that lead to green highlights. So what that means is if I were to have like A, O, A, and then A, let's do A, O, A, B, and then A, X, X, let's AAXA, let's do that, AAXA. Okay, so if this, for example, was my answer, and then this was my guess, then I would have green for the first A here. I would have a yellow for one of these, but then the second A cannot match against the yellow one, which has already been matched, and also cannot match against the green one that's already been matched. So despite the fact that I've got one yellow only, and I have 2 A's that are unmatched, I won't match both of them. Even though this one is green and not yellow, it cannot match. This A over here cannot be matched against an existing green one or against an existing yellow one. Likewise, this green one can't also match against a yellow one. Every letter can only be counted one time. Given the correct answer grid and a grid representing the guess of this answer, please calculate the number of green and yellow highlighted squares. So we only need to know the number of squares. We don't have to try and solve the problem or anything like that. It's just going through and counting what colors squares there are and how many of them there are. Input format comes from the terminal and standard input, so it's just typed into the console. The first 3 lines of input give the grid representing the correct answer. So this is the answer right here. The next 3 lines of input is the guess of this answer. This is your guess right here. Your output format is printed to the terminal standard out, so you just print it to the screen. Print 2 lines of output. On the first line of output, print the number of squares that should be highlighted in green. So that's the first line of output. On the second line, print the number of squares that should be highlighted in yellow. That's the number of yellow squares. In this example, the O in the middle of the last row is correct. So let's separate these guys. The O in the middle, the O of that moo is correct because that matches the O of the IOI. So it's highlighted in green. The letter W is in the wrong place. So I've got a W here, but then there is a W in my guess. My guess the answer does contain a W, but it's in a different location. So it's highlighted yellow. So we have 1 green for the O, 1 yellow for the W. And then we have another sample case down below that kind of illustrates more about the green and the yellow. I'm actually going to write this one out. A, B, B, B. This is the correct answer. C, C, C. And this is the guess. A, Y, Y. A. Z, Z, Z. Okay, so just kind of looking at this, as far as things that are going to be green, this right here is going to be marked as green for this one right here. This one right here will be marked as yellow for this one right here. This one right here would be marked as yellow for this one right here. And then this last A here can't be marked because even though I have this green A, they specifically said that once it's matched for green, it can't also match for yellow. Likewise, we can't have more yellows on the right side than we have on the left side. So even though I've got an extra A here and I have A's over here, that one would not be marked, only the first 2. And that does give you a hint, because if you couldn't see this over here, you would know that you have an A in this position and you know that you have 2 A's somewhere else. And then B's, C's, and Z's don't match. So in this case, then I have 1 green for the A and 2 yellows for the 2 A's. Here, one of the A's is in the correct place, so highlighted green. Of the remaining A's, none are in the right place. And since there are 2 of these in the remaining answer grid, 2 should be highlighted yellow. Yeah, it says problem credits Brian Dean inspired by the Wordle app. So this Wordle app, and again, if you get familiar with this will make this a little bit easier. It's kind of a fun game, but knowing that and having a good feel for those rules would be helpful for being able to do this problem. So as far as how we're going to attack this, my first recommendation is, if you notice from this, it doesn't matter what row these are in. These guesses are on row 2 here, but they matched something on row 1 here. So because of the fact that the row doesn't make a difference, my first recommendation is to completely break this down and just make it a single string with 9 characters, or an array. You can use a string or an array. Each one's going to have a couple challenges to overcome. They're not drastically different either way. So if I get my first input for this sample input down here, if I have A, and then B, 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 and then C, C, C. And then down here I have my guess, which is A, Y, Y, A, Z, Z, Z. Okay, so first we go through one by one and we look for things that are matching. That A matches that A, so those are going to be highlighted green. Looking through here, that doesn't, oops, let me switch colors here. Back to red. That doesn't match, that doesn't match. No, 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 no. So we only have one green. Then we're going to go through and match yellows. So looking at the Y, there's no Y, still no Y. Here's an A, that'll match against this first A here. Here's an A, that'll match against this first A here. Here's an A, that can't match anything, and then the Z's don't match. Now, as far as coding this, what's going to be important to making this work correctly is keeping track of which letters have been used and which letters haven't been used. Because when we are marking these in yellow, we can visually see like, oh yeah, this A has been used. But from a programming standpoint, we need a way to know that that A has been used. So the way that I approached this problem, I chose to use strings. And anytime I had a match that was green or a match that was yellow, what I did was I just removed both characters from the string. So as I'm going through this problem, I see AA, remove both of those. When I get to this A here and match this A here, I remove those characters. You can just use substring. Use substring to cut the middle character out. Substring up to the character you want to remove. Substring of everything after the character you want to remove and make that your new output. So we're basically eliminating characters as we go. That A matches here to here, and then that's it. Another way you could do this if you used arrays is you could just replace the character with a symbol that's not going to appear at all no matter what. So for example, we know these are all letters, A, B, C, D, E, F, G. We know that there's no symbols. So what you could do is if you had this as an array, then basically you have your first for loop going through checking indexes that match. So index 0 on the first string matches index 0 on the second string. What you can do is replace this one with one symbol, maybe a question mark, doesn't matter, as long as it's not a letter. Replace this one with a different symbol, like an exclamation point, and always always replace the first string or the first array's characters with question marks, and always replace the second one with exclamation points. Once you've done that, then neither of those characters will match anything else. So you have a for loop that goes through every index. Anytime you find exact equality for my string A at square bracket I is equal to string B at square bracket I, then we'll just do A square bracket I equals a question mark, and B square bracket I equals an exclamation point, something like that. You go through to your first pass where you're comparing just a single for loop, comparing index from the string A to the exact same index of string B. Every time you find equality, you also have to count. So you're gonna have something like green plus equals 1 or whatever. So add 1 to green anytime you do a replacement. Once you're done with that, then you have a nested for loop. Your first for loop would be something like for I from 0 to 9. Then you'd have inside of that for J from 0 to 9. And then as you're going through, if A square bracket I is equal to B at the J location, then again, you'll count that as yellow plus equals 1. And then we can do AI equals a question mark, and then B at J equals to an exclamation point. And then so then when I is here and when J is down here, that'll show as being equal. We'll replace those characters again with a question mark and exclamation point, question, exclamation point. And then when I is here and J is here, that'll also get replaced by a question mark and an exclamation point. Question mark, exclamation point. And then J is not going to match anything else because when you get to this A, there's no more A's left over up here. And then those were all the characters that matched. So then that would indicate 1 green, which you counted at the moment when you found that they were equal, and 2 yellows, which you counted at the moment when you found they were equal. And that's basically all there is to the problem. So just as a real quick recap, let's kind of look over this one. Read your first 3 lines of input, combine them to a single string. Second line, combine into a single string. When the IOI. Make your first for loop, go through every index one by one. If you've got values that are the same in both, Again, depending on if you're planning to use a string. One thing to watch out for is if you do use a string, then if you do a string replacement, you have to roll your I back. So it probably is easier to use an array because you can just do a direct replacement. If you're in C++, you can use a string and directly assign, in C++, you can directly assign AI equals to like an exclamation point. With Java and Python, your strings are immutable. And what that means is that you can't directly assign a single character of a string to a different value. So essentially then, if you're working in C++, you can do a string or an array, and it's basically the same thing. Strings in C++ are basically also the same as arrays. In Java and Python, because strings are sort of special objects, we can't do a direct replacement like that. So for them, if you wanted to use the string method, then you would want to use substring to remove the character, and then take a step back on your index, because once you remove the character, then the next letters are going to shift over, and you want to make sure you check them and don't just skip over them. The easier way would be to use an array, most likely. So if you're in Java or in Python, convert to or a list. You can use a list. That would also work. In Java, you can use an array list, or in Python, I think you can just do list of whatever your string is, and then it'll just turn it into a list. But yeah, basically, first step is to read all this information in, put them into either strings or arrays, run your I variable through each index. Anytime you see exact equality, find a way to replace that character or remove it. Again, with a string, you can do a substring to remove it. Or I guess you could just do a substring from here to here and then put that exclamation point in, and then a substring from here to here, and then it'd be the same length, just with replacement. Or use a list. But whatever it is to get this so that this is not going to be able to match again, make it an irrelevant symbol or take it out completely. And then make another loop where you're going to have I going through this one, and inside of that loop, you have J going through this one. Anytime you find equality, that counts as a yellow, and then again, replace that character with something so that it won't match again. And that's basically it. Count your greens, count your yellows, and print both out, and the problem's done. So, and just real quick as a note on the complexity of this, the reason why we're able to kind of brute force this, and we don't have to come up with anything clever, is because we've only got 9 characters here. We've got 9 characters here, which means in order to compare every character to every character, we only have 9 squared, which is 81. 81 is minuscule as far as computer language goes. You can get up to about a billion, give or take. Right around a billion is when things start kind of getting slow. So since we're well within a billion, we can just compare everything to everything. We don't have to do anything fancy. All right, so that's the problem. Good luck coding it, and I will talk to you on the next one.